Oh, wow.
My name is Dr. Michael Muma. What group do I work with? That's a good question. I actually am senior scientist in the Solar System Exploration Division. Astrobiology is a term that means everything connected with the origin and evolution of life, here and elsewhere. We actually investigate and develop high-resolution infrared spectrometers to address this very complex question as to how did life arise here on Earth and could it have arisen elsewhere independently. Probably the most important thing I do is to work intensely with the younger scientists in my team. These are young people who come here to Goddard and to the Center for Astrobiology specifically to be exposed and take part in this very exciting research we're doing in the various areas. So every day brings something new to us. It's the newness, the continued discovery, whether small ones, large ones, it doesn't really matter. And in my view, it's not work, you see. It's that this is the way we wish to spend our lives in discovery, and this is an opportunity to continue doing that daily.
Well, hello everybody. Let's get my camera set up here. How are you? Great. It's a great Friday, and so I rearranged my office a little bit so I could get to the microscope a little bit easier than before. I should have realized that having it where I was first doing some of this stuff, 6 months ago was the best place of all. I want to recognize some of the people that are on with us today. We've got Chris Larson, who signed on first, Cameron Gillis, and Andrew Corkill. And who else is on here? Ken Noble. Yeah, I did. You guys got to see me playing around a little bit, just testing some sound and that type of thing. So really been trying to work on the audio part of my broadcasts, and I think I'm getting it completely licked. Who else do we have here? Mike Wiesner, Friday wishes to everybody. Aaron Thompson, hello. This is wild. What are we looking at? Today's subject is the amoeboids, or amoeba. We're going to talk a little bit about them. And who else is with us? Richard Grace, how you doing, man? And Jeff Wise. Hello, micro fans. Pekka says, good Friday afternoon, ladies and gentlemen. Missed the beginning due to the clear weather and setting up my telescope for a long night. That's great, man. And somebody else, the background is blue with blue letters. I can't quite read it, but it says, hello, Scott, glad to see you. Good to see you too. So in my journey of, again, learning, I talk about my journey all the time with using the microscope. I'm getting more familiar with using, setting up the microscope, setting up the illumination, working with depth of field on a microscope as well. You can see my, let's see if I could bring this up. Let's do it like this. There we go. So you can see my microscope that I have setting on my desk. This is a Bresser Infinity microscope. Down below, we've got illumination here. I can move my camera. So we have an illuminator down here that has an iris diaphragm. This is LED illumination. This right here is a condenser, and it's got adjustments to change the amount of illumination coming through. And then we've got our mechanical stage over here. And I've got my specimen sitting right here, which you can see is it's just a drop of water, but that's where I have my amoeba in there. There are some Paramecium, or at least one or two Paramecium in there. And it looks, there's some sort of critters also scooting around in there. So, but before I get to my live view, let's cover what the main subject is going to be. Let's see. Now I have messed with the exposure here, so let's see what happens. I adjust the diaphragm on that, and let's get the light intensity just right. Now you can see revealed here my amoeba. Let me get a better focus. Here we go. Okay. So as you see the amoeba here, this is a single cell organism. I think there's some bacteria floating around in here. And this thing has been, he's been eating stuff all day long. And the way that they eat is very interesting. So let's kind of dive into a quick PowerPoint that I made. And I will stop that sharing. Here we go. And I will share my PowerPoint. Let's just bring it up full screen. There we go. So, the thing I thought that was most amazing about it initially was just how it was named and discovered. It was this single cell animal was discovered in 1755 by a guy named. He was a naturalist and a miniature. He made miniature paintings. Okay, so I'm gonna have to look at some of this guy's paintings. But his name was August Johann Rosell von Rosenhoff. Very German kind of guy there, for sure. And he named his discovery Der kleine Proteus, the little Proteus. Proteus has a Greek mythology. It's one of the gods, I suppose. But it means that it's a protean, which means it's capable of many forms, and that is one of the hallmark features of amoeba. Amoeba, a lot of people have heard about amoeba, but actually if you went to go try to find some amoeba, you'd find out they're not so easy to find in the wild. They're clear for the most part, and they move slowly. And a lot of times it looks like decaying organic remains or something like that. Some slime molds fall under the category of amoeba as well, but there's several different kinds, and they are both predators and and they're also the type of animal that will eat on dead flesh as well. So. Or dead things, and but the specimen that I have in the microscope is a Proteus, and so amoeba don't have cell walls, so they can push cytoplasm to the side of their body, and it will make a bulge. Okay, and they make these arms start to come out called pseudopods, and they very slowly, they sneak up on something and then just kind of sit there and slowly grow these arms surrounding their prey and until they can completely engulf it. And then they just press the food right into the body, and it's digested, and then it is expelled. So they're making kind of this, you can see there's a bacteria here. Sorry. There we go. And it's surrounding it, and it makes something called it makes a food vacuole as it's surrounding it, and then it starts to digest it with the enzymes in the cytoplasm. And then it will post-digestion, I guess it just sort of burps and gets rid of the waste. So, but in the time that I had my amoeba up on the microscope, at first I'm going, this thing's not even moving. I thought maybe it was dead, but not at all. After I came back after 30 minutes, it had changed shape and had moved out of the field. So amoeba also reproduce very similar to the way that Paramecium can reproduce. They can either split through binary fission, and make a copy of itself, or it can have, a sexual conjugation where it will transfer transfer DNA, genetic material, and make new amoebas. But the thing that I guess has recently been discovered is there's amoeba also have a scenario called a midwife. Now, when it's undergoing binary fission, if it cannot separate from its umbilical cord, it'll just give up and reabsorb a new amoeba that it was making. Okay, so that's really kind of strange, but that's what's going on. They have found that there's a third scenario where a midwife will come in, will rush in if it sees that the two amoebas are struggling, and it will exert pressure out until it snaps the umbilical cord, that's wild. Okay, so these things are smart, okay? And they are, but they're very useful to humans because amoeba eat a lot of bacteria. A lot of that bacteria is harmful to us. And I'm talking about disease-producing bacteria. Amoeba are pretty indiscriminate in what kind of bacteria they eat. So that's the deal there. This photo that I'm showing you here, however, shows a plague bacteria. This is the bubonic plague, the Black Death, okay, which still exists in the world today. But it's showing some of the bacteria hiding inside an amoeba. Okay, so you've got amoeba that can protect these things. Apparently, it says the plague can remain dormant for years. So I'm assuming that these things can hide in amoeba for years. So it's just really interesting how that something so deadly and dangerous can hide out like that and not affect the amoeba, but certainly has a big effect on us. So, but that was kind of my new lesson for today, learning about this. There's a lot more for me to learn. Especially I'm really interested in the so-called cell wall, although they say that it doesn't have a wall. What it does do is it takes minerals that it ingests and will convert that into kind of a flexible membrane, okay? I guess calcium is the major component working here, and that makes the edge of the amoeba. But as you saw in the video that I was showing earlier, the amoeba can move around a lot, change its shape a lot. If you disturb it, it'll change into like the star shape, which is interesting in itself. Why would it turn into a star shape versus any other shape? But I guess it looks threatening that way. And so one of the things I haven't done in this show is really shown much about the equipment that I use, but I use a Bresser Infinity microscope. It's got a trinocular head and the MicroCam 2. And then I get my live specimens a lot of times from Carolina Biological, but I also get them from out front of our office. So that's the deal there. But we'll go back to live streaming what I've got under the microscope here. by the way, this software that I'm using to capture, there goes a Paramecium. There's two of them there. I think it's the same two that I've been looking at. But this I'm gonna have to leave up for a little while for you to see that it does in fact change shape. There's one of those you can see the tendrils coming out, and it's moving. It's like watching an hour hand on a clock move, So, and I guess I can finish off with a joke about amoeba. There are amoeba jokes out there, and maybe one of you can guess what the answer to the joke is. And the question is why are amoeba so bad at math? And the answer is that they divide to multiply. So there you go. Ba-dum-bum. Anyhow, that's what I have to show to you today. I will be taking Monday off. It's Memorial Day, so me and Dr. Barth will both have that day off, and we hope that all of you have a great weekend. We do have a Tuesday Global Star Party, and yeah, I know there's lots of things moving fairly quick in here, and it makes you really wonder, I guess I would want to do like maybe a time-lapse video or something like that to show some real movement of this thing, but there may be faster moving amoeba. So anyhow, but I love it, and it's interesting, and all of these objects these specimens look like alien type of creatures to me. Let me move this around so you can see more of just how big this amoeba is. And there is some other little animals here. Let's see if I can get a focus on them. Look at this thing in your upper left-hand corner. It looks like a baby Paramecium. Not sure. And then I think, you see the one, the object there, it looks like it's got little hair sticking off of it there. I think that might also be a type of amoeba, different type. Maybe one of you knows exactly what it is. Maybe I'm wrong. But that thing has, it looks like it's using its little hairs to kind of navigate around. Here we go. There's some more of those little guys. I suppose if we kept magnifying that we would find even more smaller specimens of life in this drop of water. But I could sit here all day and watch these things. I think they're beautiful. If you have any questions for me, regarding microscopes and microscopy, you can certainly get with me directly if you'd like to, and I can help you get into the right kind of gear if you're also into this. We don't sell all types of microscopes. We have stereo microscopes that are used for like looking at specimens like rocks, or electronic boards, those kinds of things. A biological microscope line like what you're looking through right now. And then we do have a couple of, science microscopes for fluorescence and that type of thing. That's something I still have to learn how to do. So, there's life everywhere. And it's a fascinating world. Well, until Tuesday, we'll be seeing you on Tuesday. We will have the OpenGoTo community with a live show with Jerry Hubble. Then we go straight into the 48th Global Star Party. And what else do we got coming up? We have a new birding show coming up. It's called On the Wing. And that will feature Dan George, who was a longtime birder. And he was the guy who created Bosch Shalom's Birding Council. So, and he just loves birds. He knows how, lots of things about them, such as their flight corridors and their feather structure and, all of this stuff. There's so much to learn. Another universe in itself. And you will also see Annie come back on Wednesdays to talk about the Explorer Alliance a little bit. And she was sharing a story with me just today, and she's hoping to have a special guest join her on the show. So until that time, you guys have a great weekend, and keep looking up to the stars and looking not down, but in, I guess, towards the microscopic world. It's all connected, folks. So, oh yeah. So Mike says, don't forget to close the Venus-Mercury conjunction tonight, about half a degree separation. So that will be beautiful. You know what? And Mike, I think I might be able to see it because it's clear. So thanks for that reminder there. And thanks for watching, and we'll be back. Take care. Hey everybody, Scott Roberts here with Mike Hatch, and we're here at Explore Scientific Live, and we wanted to show you the Bresser line of microscopes. Now we're just showing a few of them here. We've got microscopes that do fluorescence work, some used for metallurgy. A microscope like this can look at 3D objects, including things like circuit boards, or if you have insects or anything like that, this does an amazing job. A lot of these microscopes can also take a camera attachment, which is great.
Like these right here with the trinocular.
That's right, and we have a special camera that does that. Some of these other microscopes have a way to attach like your iPhone to them so that you can get images. This one right here has a built-in monitor, so it's pretty cool. The microscopic world is endlessly fascinating, just like astronomy is, and we hope that you take a look. Yeah. Yep.